Right, Kettlewitch, and today we're going to be having a look at animating Nifs. What I'm going to do first is just kind of jump in and show you what we're going to be doing as an end result, and then we'll get bogged down in some technical stuff about how to do it. Now, I'm going to try and keep this as simple as possible. If you've any experience, even if you don't, if you've any experience working in Nifskope, there's absolutely no reason why you couldn't get into animating Nifs. There's not much out there as far as technical documentation or anything like that goes, but it's once you've kind of been shown once you kind of know what you're dealing with, everything that's done with them, like be they doors or traps or moving platforms, they all work on the same principle. So once you've kind of done one, once you can work one, even if it's like I say, a door or a chest or something, there's no reason why you can't apply the same things to basically anything you want. So what we're going to be concentrating on mostly today are ships. So all of you are probably familiar with the longboats in Solitude Harbour, and what we're going to do, hopefully, is we're going to add a couple of things to it. We're going to play with the collision a little, and we're going to make it an animated ship that the player and NPCs can travel on. And what we're going to do is just have a quick look through this. As this is this will be the finished product. Essentially, it's just again, I'm going to keep this as simple as possible. You can do more complicated versions where you'd have a trigger or an activator that will turn the animation on and off. But for now, we're just going to keep it simple and essentially turn these into a moving platform. So again, it won't be overcomplicated. We should be able to get it done in under the hour. But again, there's like say from it's up to you what applications you use these in, and you're really only kind of it's your imagination's going to be the limit. I know people often say that, but they're very low impact. These things are called NI controller animations. It's a long name, but it's for a relatively straightforward thing. And as you can see, they can add a lot to the anima of a location or a quest or basically the world. Um, so they're part of the vanilla kit. There's nothing particularly special about them. There's no external programs or anything used. You'll find these in everything, like I say, from doors to chests, magical spell effects, and even the incredibly complicated ones that appear incredibly complicated. They're the same basic principles, just repeated over and over again. So everything from like a windmill, the windmill blades in the farmhouses that go around, to all the like massive explosions you might see in a giant fireball spell. They're essentially all doing the same thing. They're just the more complicated ones are just using the same thing over and over on multiple layers to move more things. So at the, like what we can see here now, we've got the ship has been treated as one object basically, and we'll go into how to do that. But you're just moving this one object. Now, again, um, just moving a door or a chest or that opening, that's one thing using the same principles. Why not move a ship? Why not move an island? We can do that as well. You can move pieces of landscape. Basically, any static NIF that's in the game, you can add these controllers to them and animate them. And you don't need a degree in computer science. You don't have to be. There's no rigging or skinning involved. It's just what's called keyframe animations. We'll go into it as well. But I'm just going to let this kind of go back to base camp over there and just do the full cycle so you can see. And while we're here, and just wait for this to line up. If this is a very simple way of doing it, or a very like sort of simple way of applying it, you can also do a very complicated things like making ships explode. And it's the same stuff. While this might have one controller on it, the thing that just blew up has maybe just shy of 5,000 in different pieces. And again, I know that sounds, oh my God, 5,000, but you can automate it. And again, it's on loop. It's only supposed to play once, but I have it on loop so you can see it again. And but it's doing the same thing. It's just moving multiple pieces with these NI controllers. Okay, so just one more example. So like I was saying, these are used in spells all the time as well. Even that little explosion there, it's like cards, it's animated cards. But again, there's no reason why you couldn't use it to, if the last one was an explosion, why not run an explosion backwards and summon a temple? And just going to show you the collisions work as well. There's no, we'll be, sorry, just showing you the collisions work. We'll be animating, you can animate the collisions as well as the actual object itself. So again, we'll go through it. It's only a couple of steps, but the idea behind all this, why I'm showing you all this, is to try and get you excited about it. Because when if you just sit down and open up Nifskope and say, right, let's do some controllers and move some stuff around, it doesn't initially strike you as the most exciting stuff that you could possibly do or spend your Saturday afternoon watching. But the applications are near limitless. They really are. From if you've any interest in effects, if you've any interest in basically making your world space more alive, then these things are your door in. Okay. So what actually are they? Just going to open up two nifs here. Now, I'm making some presumptions that most of you have either know what Nifskope is or are familiar with it, but for those that don't, I'll just give you a quick rundown. All the assets in the vanilla game are in this file format. That's all it is. It's a net immersive format. It is pretty old, but the game is 10 years old, and this format was being used a lot longer than that before that. But this is a viewer for it, Nifskope. It's free. You can download. This is all you'll need to do any of this work. It's really all you'll need. Let me just open up. Right. So this is the this is the actual static ship straight out of vanilla. It's the one that's in Solitude Harbor, and you'll find them scattered around, other places as well. And this is what we're going to be using, rather than sending you off. And Kendron is going to be doing a lecture after this about how to make collisions. And if this gets you, if this gets you interested, stick around for that one as well, because they're kind of connected. But what we're going to do is convert the collisions. What the collision is it's this little red box. You have an object, but you've got to tell the game engine. You put a box around. You've got to tell it how to interact with the physics system. So if a force hits it, what happens? Does the player drop through it? Does an arrow go through it? Does the arrow stick in the side? Can the player walk on it? That's all they are. So there's two main objects. You've got your 3D art asset, the ship itself, and you have a collision, which is, you can see that again, it's a red box basically. They change color, but it'll be a box around the asset that basically tells the engine these are the limits of the asset. The game engine doesn't, it could be a tower, a book, a fork, a bucket. The game engine doesn't care. It doesn't know it's a bucket. It doesn't know it's a ship. It doesn't know it's a fork. So you have to tell it, at least give it some guidelines as to how it should act, and that's what collisions do. They're also called colliders. It's the same thing, interchangeable term. But anyway, what we're doing here is these are all the different parts of, we've got our collision object like I was just talking about, and all these little blocks here all make up different parts of the ship. So I'll just highlight through so you can see. And what we're going to do is we're going to bunch we want to animate these. But like I was saying, you really kind of, the easiest way is to make all this one object. But we have to keep all these separate, because they have other information in them. This is the textures. The easiest way to think about them is the textures, but it is a bit more complicated. It's these things called shaders. It affects a lot of stuff. And what happens is the textures and the shaders combine to give you your materials in game. Now, all this has to be moved. Now, if we just went in and said, right, we'll get our animation blocks, which I'll go into, these NI controller things I keep talking about. If we just dropped one in, we'd have to animate all these ones one at a time. So every block here would need its own, we'd have to make an animation block to tell that block how to move. So what we're going to do is actually put all these under a parent block and just move that one block, so we only have to do it once. But just before we start, I just want to show you the structure of what we're doing. So we'll have a look at these together. And you can see, I'll go through how all this is done. You can see I've grouped them under a separate node, but I'll go into that. But this is what we have here. The main difference between all these is this controller here. And what happens is we have a static asset that would be in the game. That means non-moving, what we're going to do is we're going to insert what's called a controller, which will control all the overall animations. We're going to put in what's called an interpolator, and I have a little side thing here. What the hell is interpolation? So most of you have probably seen animations that run like this, that you have frames, basically. They're called frames or keys. And so if we ran these one after another, it would look like the horse's legs were moving. So each one of these would essentially be what's called a key. And the animation that happens between this key and that key, that leg going back to there are certain ways of interpolating the movement, which basically means, I've got to move that forward leg is there pointing forward, and for the next frame I have to move it back there. So how do I actually do that? You use what's called interpolation, and I won't dig into the math behind it, and there's all different ways of doing it. So anyway, for the interpolation to work, you also have what's called the data, which is, like I was saying, how does this move? How does it do, how does the horse's leg go from from that position to that position? We give it some data and we tell it, right, if that's say at position 10 on the x-axis, we want to move it back to 0 or -10 back there. So the interpolator will know that, right, I'm moving that horse's leg from the forward position back in. And basically you do all that. All that's going to be handled in 3 blocks up here. And then you have an animated asset. That's the simplest way to look at it. So we'll just have a quick look. I'll show you how to build these now in a sec, but we'll just have a quick look at what's involved. So you have your overall controller. It's got some flags. And these basically tell it, am I looping? Am I reversing the animation? Or clamp? Clamp is play once, basically. So that's the first step of control. Then you've got stuff like frequency, phase, start time, and stop time. They're your most important ones. Nearly all of them, if not basically all of them, will start at 0, and then you give it an overall time, and that's the length of time that this animation is going to play over. And that is actually important. You've got to there is some trial and error involved. You can't sit down and go I want this door to open at this speed and stuff. You can't sit down and get it right first time, but trial and error is fine. Just do it by eye. Most of the time, that's how it's done. Like you can sit down with a calculator and a pen and paper and pop it in, but it doesn't. You put it in game and there's still things kind of happen. So anyway, you've got that's that. It has a target. It's going to tell what are we going to animate, and it's going to be block 2. You can see there. Then we've got our interpolator. These you don't really have to mess with. You just kind of pop them in and it happens in the background. What's important is the data that's fed into the interpolator down here. And this has, well, again, I'll go through all this and how to do it, but you've got 3 main things. You've got an X, Y, and Z rotations, which are rotations across the X, Y, and Z axis. You've got translations, which are moving forward, backwards, and so on. They'll have values, basically. And you've got scales. So you can make things grow bigger and larger. In the explosion, as time in the ship that I was showing you that explodes, as animation goes on, you shrink all the pieces from whatever they are down to a scale of 0, so they disappear from game. Things like that. So we'll only be going to use 2. We're going to do 1 rotation, which is to turn the ship around from, like, if this is the way it's set up, you can imagine Solitude docks are there. So we're going to turn it, send it off down Solitude Harbour, get to a point about the archway, turn around back the other way, and come back. Okay, so now get down to the nitty-gritty. So This is our first, this is our vanilla asset. You just pull this from the game. And again, like I say, it doesn't have to be a ship. I think it's kind of an interesting one, basically, because you can actually move PCs and NPCs around with them. But it could be anything. It could be floating rocks in a Daedric realm, moving platforms. You could, well, not theoretically, you could turn Skyrim into Zelda or something if you put your mind to it, or at least have a Zelda-type dungeon with things flying around and like make a big jump, do a jump timing thing. Anyway, so like I say, what we want to do, we don't want to have to put in a controller, an animation controller under every one of these blocks, because the more you put in, the more that can go wrong, essentially. So what we're going to do is we're going to group all these under one, and let's get to it. So I'll probably just I might not talk as much while I'm doing this, but if I start going too fast, or if you want to say, hey, hold up there, you missed a thing, just shout out. It's no problem. Okay. So the first thing we're going to do is insert a new node, basically, because we want to get what's called a parent node. We want to parent all these onto the one node. So it's not that hard. So what we're going to do is you click on your root node, we're going to right click, go to block and insert. And down here, we're going to look for an NI node. There's one there, and there we have it here. Now, what we're going to do now is we're going to copy all these. See, if you could just kind of copy these and put them underneath, but what's going to happen then is when we delete these ones to, so we don't have duplications, it's going to take the copy with it. So what you actually have to do is block, copy. Yeah, anyway, I'll show you. Block. Now, I better show you this. If you copy, it'll copy the top level here, but because there's all this stuff underneath it, see? What we want to do is actually copy the branch, which means copy this and everything underneath it. So as a general rule, unless there'll be something we'll be doing later where we'll only be copying one, because it's a good way to show you the differences. But for now, you're just going to copy branch, and we're going to copy everything that's underneath our root node, which is the root, the block 0, basically, and we want to put it under this one, okay? So we've taken our collision object, that's the first one on the list, basically, and we've put it down here. Now, what we have to do is tell this one that now this is going to be attached to you. So this is, like I say, this is called a parent node. And the same as this, that's a root node, but it's the same kind of thing. And we have to tell it it's got children. So what we'll do, we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. You can tell by these little arrows there that we've got 7 things we want to copy underneath here. So we can tell it there's going to be 7 children. It'll be whatever NIF you're working in, and you're not stuck. If you add in 3, if you could tell it 3 children, you can change it and make it 2. You can take away 1, or you can add more. It's not a problem. And then you refresh to let it know we put in a new number, like that. Now, these, as you can see, it's got none at the moment because it doesn't know what we want to add. So all those numbers that run along, they're index numbers, and every block is going to have its own new individual one. Okay. So the first one we want to add is this block 33. And that's all you do. You click that, type it in, and see the way it's been pushed underneath into that one. So now we've copied that down, we can get rid of this one. See, if I just copy that straight down, this one will be called 7 as well. So when I go to delete this so there's no duplicates, it'll take away both of them. That's why we do it this way. And again, like we added, we've got a remove branch and remove, because we use remove branch in this case because we want to remove everything, okay? Now, so you're not all bored to tears, I have actually... Well, at the end of the lecture, I'll post up everything I'm using here. I'll post it up. I have it all zipped up, okay? So you can actually follow through. You don't have, you don't have to worry. You can get the video when it goes up. But you'll have different stages of NIF. There's like we've got 1, 2, 3, 4, 5 little stages, and then the final thing that you've already seen in game. I'll post them up at the end on one of the channels. You can jump in and just play with the ship, the finished one, or ideally you can go through all the different stages and with your own NIF or this one yourself. If you get a chance, like I said, it's the vanilla longboat, so go through it, and once you've done it once, it probably won't work the first time, but something will crash the desktop. It's just the way it is. You do it the second time, hey, you've got animated chips and you know how to make them. So like I say, just to save some time, what I've done, I can show you now. Where are we? You'll have to forgive me. So as you can see here, they were all kind of loose, and all we've done here is just copy them over, and we've made them all underneath this. It's got 6 children. Always good to keep the names. If you're not sure, when you copy the block down, if you click that little text, if you select your block and click that text there, you can call it whatever you want. But it's something to keep an eye on. Every block has to have a unique name. It's not a huge deal right now, but if you start having problems or you start getting errors that like this block is incorrect, it's called something different, that's usually where it is. Just you can call them 1, 2, 3, 4, 5, or you can give them a descriptive thing like the shield details, the trim, the mast, whatever. It's not a problem. But it is Nifskope won't actually see these ones here. They have the same name, but they've been given a number index to keep them different. Nifskope will actually do that for you. If you go to spells, sanitize, reorder blocks, it's a little built-in thing. It'll put a little number after it and stuff. It's just something to watch out for, that's all. So this particular NIF, we've got these things called BS Lod tri-shapes, right? And what they do is, most of you, anyone who works in level design will know that you have these things called LODs, or level of detail. So when something that's fairly complicated is close to the player sees it as it is. But if it's further away, because the player probably won't see things, see the shields are disappearing when I change the LOD there. So when that boat is in the distance, you can save yourself some render budget. You can get rid of some polys basically, so to keep the frame rate up, stuff like that. It's optimization. But because this is going to be animated now and the player is going to be on it, we don't really want the LOD shapes. We don't want the shields disappearing, while the player is on it. So all we're going to do here is change these LOD tri-shapes into these NI tri-shapes. Now, the NI tri-shapes, some of these, if you're not used to Nifskope, the terminology can throw you off. You go like, NI what now? Who did what to the tri-shape? But they're just groups. They're just ways of grouping it. So this is a group of shapes, and it's the hull of the boat. Don't let the names throw you off. So it's kind of like what we were just doing. We want to convert these LOD tri-shapes to normal shapes so they don't disappear at distance, basically. And it's dead easy, so it's pretty much the same as we were doing when we were grouping everything. We'll give ourselves a new block. We go insert, and we'll go down to NIT. See the way there's so many different ones you can work with. We'll mostly be working NIT ones today. So you can see NI tri-shape there. And what we want to do is copy the data, which is the raw mesh. It's the actual mesh, if you like. You can see down here, like the vertices, center, vertex colors, all that kind of thing. So we just go back now. Instead of using copy branch, we just want the shape data. In this case, we don't want to copy everything that's underneath it right now. So we're just going to go copy and paste. And that's that. We go into the shape, and like we told the NI node that you're a parent now, and these are your children, we're basically doing the same with these, except in this case, it's going to be data of the tri-shape. So click in there, its index is 34, so we'll tap that in. Oops. And now we have the shape data. Now we also want textures to come over. So this is a block. It's like I said, it's got your shader and your textures. So same thing. Only this time we're going to use branch because there's more than one thing there. And we go back in here, and you can see it doesn't have a shader property there, so we just tell it the number of the one we want to use. And there we go. And which one was that? Get rid of this one. Again, remove branch because we want it all to go. And we go back into this block, and you can see here, because we just deleted that, it's kicked out a child. So all we do is tell it what the number of the new one is, which is 2. And no have if you're you can work away basically if you're confident in Nifskope, but if you're not, or it's just like your first time in it, or you just only started using it, again, block, sanitize, reorder blocks, and it'll make it all nice and neat basically and push everything into the right locations. And again, there's 2 other blocks. Just you do exactly what I did there, and just to kind of keep us rolling along. Here's one I prepared earlier. And you can see now we have a block, and all these are just NI tri-shapes. So you can see that little slider thing is gone now, and that just ensures that none of this geometry is going to disappear while the player is on it. And again, it's there's ships and trees level design stuff is mostly where you'll find that. If you could experiment with it, I'm not saying you have to do this, but it's just because of the way we're changing this from a piece of static level design into something like the player or NPCs are going to be using. It's the same with like a moving platform. You could say it's just a rock, but if we start moving the rock, the player's going to be right up on it all the time. So, ideally, you don't want parts of it disappearing just because of render budget. Okay, so now what we're going to do now is start working on our actual controller. So as we've been doing, we're going to keep using this block insert. And that's really all there is to it to add stuff. And you can, obviously you've seen how we can remove stuff as well. So what we want to do now is add our NI controller. There's 3 things, if you remember: the controller, the interpolator, and the data. So the first thing we want to do is add in NI transform controller. We go to our block, our grouped block, basically, and you'll see here there's a slot here for what kind of controller. These are used in effects a lot, not just transform controllers. You have these things called effect controllers, but anyway, they're the same principle, but they do slightly different things. So we want this new controller in there, so we just tell it that that block number 2 is going to be our controller. Okay, so once we have that done, we can just click there. Now we go to our controller, and we have to tell it to tag it. Okay, you've got a block of static stuff, and I've put in a controller. What am I controlling? What am I going to be moving? You're going to be moving this thing here, block 1. So we just tell it. And now, yep, now it's going to look for an interpolator, a second one. So clicking on this. Okay, so now we've got an interpolator down here, and we just have to tell the controller this is the one we want you to use. And just like you'll see a pattern, you see a pattern here and stuff. This is all this really is. It's just knowing what blocks to cut and paste in. But this is all you're going to be doing. All you really need is Nifskope. I should probably maximize this. Sorry. But all you're really doing is cutting in blocks and kicking out other ones and being able to manipulate the hierarchy in Nifskope. And there's a lot, and I mean a lot, you can do once you kind of get that under your belt and kind of understand what's happening. So now our interpolator, we know we need data, and it's looking for one there. So we click on that, we go block, insert again. And you'll see all the ones we're working with are in this NIT one, so you don't have to worry about the other ones at the moment. So it's NI transform data. And again, just tell the interpolator which one we're going to use. Okay. Now, when we just flick back here, these things are flags. Do you remember I was showing you that there's 3 types: cycle or loop, the animation, run it in reverse, or play it one time. So you can click it here, cycle, active, and it changes. Well, that's not actually what we want. What we actually want is Yeah, sorry about that. What we actually want is 72, which active loop mode cycle, which is what we clicked, but it only came up 8, which you want to pop in 72. Once you have that in, you can change this, like I say, and you'll see it changes along with it. I'm not sure why it came up 8 there on the first one, if I'm honest. So we'll pop that in on the controller. Now, also, we have to tell it what's our start time, what's our stop time, okay? So in the controller again, we're going to tell you to start at 0, and our stop time, we're going to choose 240. It's seconds, essentially. Okay? So again, like I say, I'll post these so you can have them all at the end. So now we've got our controller, flags, frequency. You don't have to worry about that. You can speed things up basically with frequencies and phase, knocks them out of sync a bit. It's fun to play with, but I don't need it right now. Our target, our interpolator is this one. And then you can see the way it forms a chain, and it comes all the way down. And then we've got data there. Okay, now I'm going to go back and show you, bear with me. We'll have to add in some stuff for the data. Now, here. Sorry, I just want to find the one that doesn't have those, so I can show you how to put them in. Okay. These will actually come up. Yeah, cool. They'll come up blank. But what you'll end up having, sorry, no, so I actually wanted to catch one that didn't have any values in it. Let me see, I might go back and make it. It's kind of important. I'll just do this quick. Now, this it's the transform data when you put it in fresh from a block, when you're not using, when you're not messing around with it, it'll come up basically really blank, and there's some very important things you have to set up under it. So what you want to basically to tell it that it says number of rotation keys, but basically what this is either 0 or 1, and you're basically like, is there any actual data in this? And while it says rotation keys, it's basically for all of them. It's like the scales, translation, and all that. So what we're going to do is turn that to 1, and you can see these change. Now we have a rotation type down here, and the rotation we want to put in is XYZ rotation. There's a drop-down list there. You can use other ones, but again, they're used for different things, spells and stuff. Okay, so now we have 3 things. We've got our XYZ rotations, we've got translations, moving things left and right, and scales. So what we're going to do for the thing I showed you is go into rotations. Now, as you can see, this is called XYZ rotations, and there's 3 entries underneath it. The first entry is for X, the second entry is for Y, and the third entry is for Z. So if I select this one, I'm going to be rotating things on the X-axis. If I select the second one, the Y-axis, and Z. It's not particularly clear because they give it the same name, but that's how you know. So we're going to rotate on the Z-axis because we wanted to kind of spin around the center, if you like. So we'll go in here. Now, if you remember back to the horse, that there was like a number of keyframes, and the animations are interpolated between them. We have to tell it how many keys we want. So on this one, we're going to use 4, which is not, it's one position, turn to a new position, go to a distance, turn back to the position. There'll actually be 4 steps to it. Now, the more keys you put in, the smoother your animation is going to be. So with 4 keys and considering the distance that the boat went, you could probably see when I was showing it to you, a little bit janky, but it's to keep things as simple as possible. If you want to make the animation smoother, no less ripple or whatever, you put in more keys, but it's not something, there's very little you wouldn't be able to do with under 10 keys. Like there's no real point. I'll put in 100 keys kind of thing to make this super smooth. Human eye probably won't notice the difference. Certainly not in this engine. Like maybe if you were in UE4 or something, you could go a lot deeper, but you're not going to need that many number of keys to get a reasonably smooth animation here. Okay, so what did I say? 4. And again, here's our old friend interpolation back again, and this time we want to set it to quadratic key. And you can look these up on all these different types of interpolation. You can just throw them into Google because they're not some magical thing in Nifskope. They're used all over the place. They're pretty standard ways of interpolating animation. Okay, so now we've told it we have 4 keys. We're going to use quadratic key as our type of interpolation. Now we have to tell it, you see we've refreshed there and you get a little drop down menu there. So now we've got 4 keys and we can open them up and you'll see they have values, the time. So at what time, what value, like how much of a movement or how much of a rotation, and do you want it forwards or backwards? Again, we're going to keep this as simple as possible. Most times your keys, be they in rotations, translations, or scales, start at 0. It'll just save you a lot of headache, basically. That, right, I wanted to start at 5 minutes and do that. It'll always keep looking for, it'll start itself at 0, basically, so you might as well start at 0 as well. So your first entry, right back here, see, we've got a timeline now. It's not going to do anything, but it'll just count up to 240. But so our initial times 0, 0, we'll just leave it at 0. So here on the next step, I type in after 60 seconds. I want you to have a value here of, we'll say, minus 1.5. Now, these are in a type of radians, basically. The easiest way to, I'll post up something with the files at the end of it. That's a converter, essentially. But basically, it's like 1.5 is about 90 degrees. 3 is like 180 and so on. You don't have to worry too much about it. You'll figure out there's like 90, 180, 360 are the main ones you're going to be using to turn things around in rotations. So you don't have to go off and learn how to convert radians to degrees and all that stuff, whatever. Again, I'm a big I always advise kind of like trial and error. And even if you've never heard, even if you don't know what a radian is, if you sat down and just played with it, you'd figure it out in like 5 minutes about like how much how much turn you're going to get for what values and stuff. Honestly, so we're going to go on to the next one. Halfway mark of our animations. Okay, so it's going to be 120, and we're going to use 1.5. Which will, let's see if it does it. Yeah, and I have to do all of them, and the last one, 240. Now, this one's really, really important. Your final key, your sort of end time, it has to match the end time in the controller, or you'll just get a crashed desktop. And it can be incredibly frustrating because even if you're off by like 0.1 or you put the decimal point in the wrong place or, the cat jumps on the keyboard while you're doing it, you can be hunting it for ages. So that's the first place. If these animations don't work for you and you're kind of going, what the hell is going on? First thing to try is to make sure that your start time and stop time are your start time and stop time in your keys. It's absolutely crucial. Okay. So I'm going to leave this value at 0. So what we're doing is we're starting at stop, Going to push out, rotate a bit around, rotate back, and this is the lazy way of going backwards. Now, ideally, you put it like these. I've got 3 keys to get to halfway, so doing the reverse 3 back, that'll get you nice and smooth. But because these are going to be interpolated on the way out, you can kind of cheat and just say, right, bring everything back to 0 after after halfway through, and it'll follow it back through. Again, it'll there's certain animations you probably want to do more, but to start with, no problem at all. Go halfway, and then just go to the full time and bring everything back to 0, or whatever the start value, the like start values after the 0 entry are. There you go. Because this is, I'll speed it up because it's going a bit longer. So it starts at 0. Let's see where are keys. And when it gets to 60, it's going to have moved minus 1.5, which is 90 degrees in one direction, clockwise. When we get to 120, move back the other way, go back to the way you were, and then when you get to the end of the thing, go back to your initial position. Okay. So that's our rotations. Now again, there's nothing stopping you using scales and making this thing giant or small as it goes along. But actually, I just saw the time there. Sorry, so I'm going to speed things up. So now in our translations, we want to move it on this axis so it actually, moves forward. So same principle. I'm going to give it 5 keys. Give it an interpolation type, quadratic again. Now these are just axes. It's the same as the rotation values, but instead of degrees, we're moving along x. See the little axis thing there, x, y, and z. So you've probably, anyone interested, you've probably figured out that there is nothing stopping you turning this into an airship. We're going to be moving in the x and y axis, but if you were to add values into z, it'll go up in the air and it'll bring the player with it. So you could, on paper, I'd love to see somebody, do it if this is any interesting. You could fly it over the Solitude Arch Bridge instead of going under it just by adding values here, but there's something for you to play around with. So again, I'm a little bit short on time, so I'm going to push forward. And this one has all, again, like I say, I'll post these up, so same principle. I think I'm cheating again with this. Yeah, so it's going to go up to the Solitude Edge. These values are just, they were trial and error. There is a unit, like a Skyrim unit is equal to so much on that. But again, you're better off. I would consider, like, with stuff like this, and especially at this stage, don't worry about sitting down and doing math. It'll just put you off, unless you're really into math and physics. It'll just put you off. So just put in values and play with them. So again, what we have now, you'll see we're going to be rotating. If you remember our rotation things, but we've also got movement along that axis, and that's what takes the ship up. Get to about 120, turn around, and like I say, we're kind of cheating by just setting everything back to 0, but it works. Okay. End times have to match, like I was saying again with this. It's if any of these are out, start time and end time have to match the controller time, or it gets very unhappy, and that'll make you unhappy. Also, because we've got an animation in our thing now, see, we've got, these are called BSX flags. They're overall controlling flags. Will I turn animation on, Havoc, which is a different kind of animation. You've got Ragdoll, you've got all this stuff, but basically all you need to know is for something like this, you just can change this to 139. And if you're doing something different, like a door or a chest, the easiest way is just to go find something in the vanilla build, like in actual Skyrim, and see what the flags are for. Like, they'll be different for a door and a chest or whatever. But once you kind of get into it, you can go in and just click them by hand. But bit 0 has to be on for any animations to work. These are, I think it's least significant bit binary, and that gets converted into decimal. automatically. Again, there is math behind it, but you don't have to dig into it really. Not at this stage, anyway. Okay, so now what we've turned the static longboat. Just one more step to go. I should be on time. We've turned the static longboat into a moving one, but we have a small problem now. Is that if we look at our collision, they're still set to be a static. That basically means if you were to load this Nif straight into the game, it would definitely crash the desktop, because you're animating something. You're telling the engine, we've animated this ship, and yet on this one, on the collision, that really important thing that decides how these things react with physics in the in-game engines, you're telling it it's a static. So that's going to crash the desktop straight away. So what we have to do is tell it that, right, I want the collision object to move with the ship. We're going to animate both of them. In Nifskope is fantastic, but it's not any guarantee. You can basically, because I've moved this collision underneath the node here, in Nifskope it's moving with it, but that is absolutely no guarantee that the game engine will see it that way. So as much as I love Nifskope, the only way to know is in game. If you're having stuff. So what I'm kind of getting at is, if it works in Nifskope, it doesn't mean it's going to work in game. So just be aware of it. So anyway, there isn't that much to do to change a static. Again, like I said, I think kind of the next lecture that's coming up is going to go into a lot more detail than I am about what these are doing, how to make them and stuff. It's going to be really good stuff, I know. But just to the bare bones basic, how do I turn a static collision? It's really the rigid body, but nitpicking. How do I turn this into an animated one? So you've got these two things coalesced. This is the collision layer, right? And you'll see down here, it's tied into Havoc, which is it's a third-party physics engine that Skyrim uses. So you'll actually see this can throw you off if you don't know about it. There's two, okay? So that's set to a Skyrim static. And what we're going to do is change this to animated static or anim static. And you have to do it in both layers, okay? So now we've told the engine, this isn't a static anymore, this is an animated static. And you've got all these physics. Again, don't let this stuff, if you were to Google any one of these, you'd get a good explanation. But in general, it's for tweaking the rigid body, for getting it nice and extra nice and smooth, or getting it to do something special. That's when you have to start worrying about stuff like mass, linear, and angular dampening, and so on. Really, what we're interested in is the motion system right now. So the motion system type, you've got MoSys box stabilized, right? What these are is they're spheres and boxes, a thin box, or this. It's like a bare bones. How should my object act, basically? How should the rigid body act? So if it's a sphere, it'll probably roll over if it's top heavy. Like if you make that ship a sphere, because there's weight on top, it could end up rolling over on its side. So we're going to use, and again, I'll try not to go too deep into it, because the next lecture will. So we've got motion box stabilized, but we're going to move that to motion box inertia, okay? Solver deactivation, you can see it's turned off. So the solver is basically when a force hits the collision, I have to solve what's happening. And if it's static, it doesn't have to be on, because no matter what kind of force hits a static object, it's going to stay static. So that's what it's set to by default on these static things. So we want to turn that to low, which basically means if you're hit by, you can turn it, it makes kind of sense, if you turn it on to low, if it's hit by a rock on the side, then the impact, the force, will be kind of treated as a low impact. Whereas if you had it on high, it could send it halfway across Whiterun, sort of thing, And the quality type that's initially set to invalid, so we just want to change that to fixed. And that is essentially it, as far as the Nifs go. Again, this will be the final one. This will have the thing with the rigid body, and that'll be actually. These are the things I'll post up. That'll be the one that are actually used in game, and there'll be an ES. I'll throw the ESP in, and because do I have time? I do. I'll just show you very quickly the creation kit entry, and it's dead simple. It's movable static. You give it an ID. you link it to your model. This thing is very random animation at start. You could probably turn off, or obviously it'll pick a random place in the animation to turn off to start, so you can turn that off. This is very interesting. This is what allows if you could select collision geometry on this nav mesh generation import option. It allows the ship to act as what I call a pseudo nav mesh, basically. So just before I finish up, I'll jump into game quickly. I'll agitate some of the guards on the thing. They'll follow you on and fight and run their AI packages. And even though it's not nav mesh, NPCs, as long as they're running an AI package, if they're not actually running an AI package, then they'll basically jump off the ship and go find the nearest, real nav mesh, if you like. So that's like I said, this is just a movable static. The movable static entry, it'll basically it'll load up the asset and it'll play the animation. So things like the windmill, it's doing its, the windmill blades, they're just turning and doing their own business. Perfect for this. Now I've used it because it's simple, but really, if you want to kind of go the next step, you'd use an activator entry, and have oh, I don't know, like a bell or something, or a wheel, control wheel, just another little object on the ship. And when you go up and activate that, when you press your E button, that starts the animation, and you could stop the animation mid-through by ringing the bell. There's all these things. But that's really just an on-off switch and stuff or whatever. It's a little bit out of, like I say, I'm running out of time here. But all you really need to play around with is a simple movable static entry into the thing. Link up your NIF, and that's it. Place it in game anywhere you want. So again, if I just in the final one, in this data, if I was to give that scales to, so like I say, that's how easy it would be to make the ship, what, 10 times its size? And it'll bring the collision and everything with it. So you can kind of see how, like that, going up that big and coming back down again, is how explosions are done. There's something that, like they're broken into pieces, yes, but they're, it's effects basically. So anyway, okay. So yeah, if there's any questions, we'll go for it. Like I say, John, it's that option. Basically, what it'll do is, if there's no actual nav mesh available, it'll use the collision of the object as nav mesh temporarily, while there's an AI package running. The NPCs and stuff, they don't like using it. They'd rather have, like proper triangled nav mesh. But if it's not there, they will use it, and they'll use it quite happily. So I can post up some videos later, some some tests I've done. But you can have whole groups of, say, soldiers or whatever. Hey, Avalente, how you doing? So you can have whole groups of soldiers on a ship. You give them the AI package to hold location. They'll hold the ship. If an enemy, a good one to do is Stormcloaks and Imperials. Get a ship, fill it with Stormcloaks, give them a whole package. Get another ship, fill it with Imperials, give them the whole package. Send the two ships, from one end of Solitude or whatever. No, like I say, if they have the whole package, they'll basically treat that, the collision, as nav mesh, and treat that nav mesh as the location they'll hold. What happens is, if you were to fusto them off the ship, then they'd be in the water, so they wouldn't be on any nav mesh, and they'll always choose real nav mesh over the pseudo nav mesh. So it would be like, if they were, instead of a ship, if they were on moving platforms in a dungeon crawler, and like the platform is going up and down and you've got some archers on it, they'll stay there and shoot at the player happily. If you blow them off the platform, they won't try and get back up on it again, which, it's not the end of the world. Okay, if anyone has any more questions, I'll take them. Otherwise, I'll go post up all the files you'll need to play around. Might dig out some other videos and stuff. And again, if you think of if you think of any questions after the event, ping us. Just ping us in the lecture hall chat, or I'm. Oh, I beg your pardon. Why do you have to do anything with the large shapes? That's good practice. Basically, if you have specifically for ships, Minji. Technically, you don't. You could just group them under and not have to worry about changing them. But if you had a group of NPCs on a ship, like the end of Lord of the Rings, if the player's standing on the docks and you have a group of NPCs, you tell them to go onto the ship, say goodbye to the player or for whatever, and they drift away, and the player's waving them goodbye, and halfway, a couple of feet away from the things, half the ship disappears because of LOD. It's a little bit immersion breaking and stuff. Yeah, essentially. Yeah. No problem. Okay. Like I say, anytime you have a problem, or if you have any problem running through the stuff, like I said, I'll post it up. Ask any questions you have in the lecture hall or wherever, and you can always find me at the AU. I'm here most days. Okay. Thanks, Ash. Okay. Thanks again, and hope you enjoyed it somewhat.